Good morning, dear students. In the last session, we have started with the classification of the size reduction equipments. We have discussed the jaw working of the jaw crusher. Basically, the principle in the jaw crusher, that is the compression. There are two jaws. One jaw, that is the fixed jaw, and the second jaw, that is the moving jaw. It forms an angle of 20 to 30 degree with the fixed jaw, and material is caught between the two jaws, and due to the compression, the next type of the crusher, that is the xylophone crusher. Again, here the principle is the compression. Now if you see here, this is how the size reduction is take place into the jaw crusher. As we have already discussed, one, that is the fixed jaw, and second, that is the reciprocating jaw. As this jaw moves in this direction, due to the compression, your size reduction is take place. Now this is the example of the gyratory crusher. In the gyratory crusher, this is our crushing head. So if the bucket gyrates in this direction, then the size reduction take place over here and material is taken out from here. If it will gyrates in this direction, the size reduction is take place over here and the material is taken out from this place. So if we compare the jaw crusher and the gyratory crusher, in the jaw crusher, the product is we are getting intermittently, where in case of the gyratory crusher, we are getting the continuous product. Now this is, as I told you, we have the funnel shaped casing at the top. The crushing head is mounted on the heavy shaft. This is the shaft, this is the crushing head, and this is the funnel shape of the casing. So this is the crushing head moves towards and then away from the stationary rod. So as it moves in this direction, the compression force on the particle is take place and the size reduction is take place. So the material is crushed at the same point at all the times and discharge is continuous. So that is how the gyratory crusher works. The next hammers are the swinging hammers. As the particle or feed material is taken inside, it will strike on the material and due to the impact, the size reduction is take place. At the bottom of the casing, we have the screens. So once the size reduction is reduced up to this size, then and then its material is taken out from the screens. This is again the example of the hammer. And the next, that is the roll crushers. So basically there are two types of the roll crusher. One, that is the smooth roll crusher, and second, that is the toothed roll crusher. So again here the principle is the compression. Now if you see here in the diagram, there are two heavy metal rolls. They are turning on the same parallel axis and in the opposite direction. The speed of both the rolls are also same. The material is taken from here and this is the slip region. Now this region is known as the slip region, where the material is taken over here. This is considered as the nip region, where the compression force is on the particle, and finally the material is discharged from here. So if you compare the roll crusher and the hammer mill, in the roll crusher the material is nipped only for the one time. The feed is coming from here, slip region, nip region, and then the discharge. Where in case of the hammer mill, as per the requirement, जब तक आपकी स्क्रीन के मुताबिक उसकी साइज रिड्यूस नहीं होगी तब तक it will inside the casing and the hammers will strike. So this we will discuss in detail in the lecture. And the important point in the roll crusher is the angle of nip. So the definition of the angle of nip, that is the angle formed by the tangent to the roll faces at the point of contact with the particles to be crushed. So if I consider this is as the particle, if I draw the tangent where the particle and rolls are in contact with each other, the angle which is formed, that is known as the nip angle, and that is denoted as the 2 alpha. And this is the sum based on the roll crusher that we are going to discuss in detail in the class. Thank you.